Hello everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today we've got Sangdon who has just completed the course ROS2 Basics using Python. So you'll be giving us a presentation on this. So we'll first begin by seeing his code running on the real robot, and then we'll allow him to get into the details so that he can get us to understand how he managed to accomplish the task. So without any further ado, let me now hand over the platform to him so that he can begin his presentation. Alright, whenever you're ready, Sangdon.
Okay, sounds good.
Alright, so your code is already running, I can see.
Yeah.
Alright. I would recommend maybe that you start afresh so that we see how you got there, how you got it to run. So
Oh, okay, so you want me to explain first and then run the code?
no, I just mean the procedure of running it. Right, so what are you running first and end?
Okay. So first it's gonna do the find the wall, and then it's gonna up once it finds it, it's gonna approach the wall, and then after it reaches a certain distance based on the instructions given in the course, it's gonna align to the wall, and then while it's aligned, it's gonna start moving, which is gonna follow the wall, and while it's following, um,
So
in the section, yeah.
yeah, okay, so what we wanted to see is the whole process of finding the wall, then align with the wall, then follow the wall, right? That's why I was
hmm
saying, if you don't mind, would you start from scratch? So you stop the robot and then position it in some place, then let's start the whole thing.
Oh, you didn't see it. So I place it right here, and then uh, it's gonna like it rotated to the clockwise. You didn't see that part,
Mm-hmm.
or you want me to start all
Yes,
over
yes.
again?
So our viewers didn't see that
Okay.
part. I saw it,
Oh,
but
okay, I
not.
see. Okay, I see, I see. Okay. So currently the robot is, I don't know, it might detect the wall in front, but it's supposed to turn clockwise and detect the wall on its right side and then move closer. But let me just adjust the robot just in
Mm-hmm.
case.
Maybe move it to where there is no pathway. Yeah. So you put it in on the arrow in whatever state you want to put it, either facing the wall or not facing the wall. But we want to see that it's looking for the wall, right? That's the most important part.
Yeah, sounds good. So after that, you might want to move the robot to a certain position, and then if we launch the code, it's gonna turn clockwise, and once it finds wall, it's gonna move to the wall,
Mm.
and then after it reaches a certain distance, I don't remember the quiet specific distance. It's in the code, but after it reaches the threshold from the wall to the robot, it's gonna start aligning to the wall. And then after it finishes aligning, it's has finished all the steps for the wall following process.
Mm.
So it's gonna pretty much follow the wall the whole time. And then after it follows the wall and it reaches the initial position, it's gonna return the lead of the o- the odom points. Odi, I don't know, like odom. Did I say it right?
Mm-hmm. Mm-hmm. Yes, you
That's
did. Okay.
those words.
Yeah. So okay. While we're still on that note, right? What happens if it starts facing somewhere where there's no wall, right? So for example, if you would do this test for me, so you stop the robot and then you make it face the cones or the cylindrical blocks in the center there. So I want to see the
Oh, right
process
now.
of finding the wall in that state.
Okay, so do you want me to like the face the
Mm-hmm.
cone?
Yeah. So you set it
Okay.
facing the cones and then you stop execution here. Then you run your code again.
Okay. Um, I think I have set it up as like that.
Maybe a bit more so that it's almost perpendicular, right? Yeah, something like that. Yeah. Then you can run your script again, and let's see.
Um,
Say that again. I don't think I heard you.
no, it's good. It's good.
Okay.
Uh, yeah, I guess I didn't really think about the
Let's
part
wait
where
for
you
it.
faces.
Yeah. So yes, that can be a bit difficult, but let's wait for it to see if it will change behavior. Okay. Right now it's struggling quite a lot. So stop again and then move it to a different spot, but also don't make it face the wall immediately, right? Okay. Right now, I wonder which wall it's following.
Uh,
Yeah, okay. Stop execution and then let's move it to a different spot.
okay.
So, okay, as you do that, can you. Okay, maybe there might be too many things for you to do, but if you can answer the question. So, um, how is it finding the wall? Are you just making it rotate, or there is something algorithmic that you're doing? As in, is there some specific criteria that you say, okay, if you get this much laser scan indexes, or giving you a particular value,
So
then
I
it's a
pretty much
wall?
yeah. So I pretty much at first I used a single index value, which was 0 degrees
Mm.
for the front like index value.
Mm.
But when I used that, it was giving me too much offset between the minimum distance from the obstacle and the front index distance. So I used the 20 degrees. So I
Um,
used the
I don't think I
10.
understand what you meant there. So you said when you used 0 degrees as the only index you consider, what happened?
Yeah, so at first, and I was having hard time making the program work. So instead of using one index value,
Mm.
I used degrees. So I used try to give the robot 20 degrees of the view for the front part.
So use a
So
range.
I use a range. So I use a 10 to
Okay.
350. So I gave the range of values, range of pretty much indexes, so it will have more wider view of the front obstacles.
Okay. So which worked for you the best in this current state, right? So because we're probably going to look at it anyway after we execute it for the second time, but off the top of your head, what range of values or angular sector worked for you?
So pretty much I tried like the 30, 40, but once the angle gets too big,
Mm.
it's gonna start uh moving to the wall front like quicker
Mm-hmm.
than you expected. So but you still want to make the robot find the wall. So I use a 20 degrees. That's why I use 20 degrees. But I think you could still use I think wait, I think I changed to 10 or 20 is both. But I think I use 20, but I'm pretty sure you can use 10 degrees as well.
Mm.
It's just that if you only use the 0 degrees as your front index value, it's gonna create too much it creates too much offset for me. So that's why I use the degrees.
Okay. All right. So okay.
Oh yeah, so I use 10.
While we are on that note, and also like the finding the wall, because we are testing finding the wall right now, right? So can you tell me how your algorithm distinguishes between a wall and an obstacle? Did you put that measure in place, or basically right now there is nothing that does that?
Also, can you repeat the question again for me?
So how does your robot know that this is a wall and this is an obstacle? Like, did you put any mechanism to do that, or it's just
So
look for something?
I should have done, I should have done the obstacle mechanism for
Mm-hmm.
the wall.
Mm.
Because for instance, obstacles, you will only be detecting the obstacle for like a certain amount of times. But for the wall, you'll be detecting the whole time on your right index because you are gonna follow the wall. So I should have added the algorithm where it says if it doesn't detect the obstacles for more than a few seconds, then it should recognize it as an obstacle.
Mm.
But if it's uh recognize this like obstacle as more than a few seconds, let's say 5 seconds,
Mm.
it's definitely gonna be a wall because there's no other obstacles that is longer than the wall in
Mm.
this environment.
Mm.
So I should
Okay.
have added that, but yeah, I guess.
It's an interesting way of doing it, because I was thinking of this doing it this way, right? So you look at this, the ranges that have got same values across maybe
Mhm.
a wider angle, for example. So if we're looking at the wall at like 20 degrees, you're using a sector of 20 degrees, then if all 20, let's assume there are 20 indexes in that 20 degrees, which I don't think it is actually, but let's just say that all 20 indexes would have the same value, right? So this is what I was thinking is a criteria, but yours is also very interesting because you're saying if it sees this thing for more than 5 seconds and this thing does not change. Yeah, it's an interesting way of doing it. Anyway, can you execute now the script so that we can see it try to find the wall in its current state?
Yeah, sure.
Okay.
So I was wondering why is there like a delay of when it turns?
When it turns.
Yeah, so when it gives like a new command, I feel like there's like a delay, not delay, like the movement isn't really, how should I
So
say?
I think it's a latency issue, right? That's number one. Or number
Okay.
two, sometimes if it's angular velocity commands that you're giving, the motors might struggle to initiate that angular velocity to initiate the twist, right? Because the motors have to rotate in opposite directions. But um, basically, we haven't had much of an issue except latency. So I'm thinking for you, what you're experiencing is latency.
So how can I fix the issues? Do I have to like give the callback more frequently, like in shorter time of range, or like longer, or
Okay, so that is interesting. You could try to do that, but beyond a certain frequency, you just saturate the robot, the hardware that is running on the robot, right? Because if you pass too many messages, it's gonna drop off the excess ones, right? But it
Mhm.
does help in other cases, if your packets are being dropped somewhere where it is not the robot hardware that's giving you that compromise, right? Um, but the specified frequency in the ROS jack should be okay if you have stable internet. That's why I was saying I think for you it's latency depending on where you are and what you're doing. But I can see there you've got 100 milliseconds. It should be fine.
Oh, okay, I see, I see.
Yeah.
Maybe I can change it.
All right. All right. So this was good. It's good. We can see that it's managing to follow the wall correctly. Now, can you maybe show us the code in more detail and then you can run through it step by step or function by function so that we understand more a bit what is happening when it's trying to find the wall? Because I think for me that is very interesting in the nature that people approach that problem. So that's why I said let's look at the code.
Of course. Let me see. Hmm. I guess like the distance between the where the initial point and where I arrive is too big, so it's not giving us back the list of record points. It's 5 centimeters, but I guess it's more than 5 centimeters.
Okay, so
So,
the interval for the statistics.
yeah,
So
because I
what frequency is that
was
running
given.
at? Let's see. I would recommend you open your IDE for this so that we can look at it in detail. Yeah,
I
maybe.
mean, currently I give it at like when the return distance is shorter than 5 centimeters, then it stops recording.
Mm-hmm.
Sometimes when it's like so big, the difference is like too big that it's not gonna. So when I did it with like a zero point 0.1, like a zero point 0.2, like 10 centimeters or 20 centimeters,
Yeah.
it had like it definitely give the values back, the record points back. But 5 centimeters, sometimes it does, sometimes it doesn't. So I guess it's not constantly moving as it's
Mm,
supposed to.
yeah, well, let's go down a bit and let's see. Because I also want to see how this odom recorder is being spun. So,
Just let me like to 15 centimeters if you don't mind and see if it actually returns the points.
oh, okay. So if you're talking about stopping, right, and okay, moved enough, return distance, that one. Okay. Uh huh. I see. All right. Yeah. Try changing that and let's see. But then you have to stop and execute again. So,
Yeah.
because right now it didn't stop. After it got to the initial point.
Well, for the indexes that what you said for the 10 degrees couldn't be uh so I'll probably have to make the degrees bigger because I feel like if we look at the small like wall thing, I don't know what you call this small stone thing, then I
Yeah.
feel like if it's 10 degrees, then it's still gonna probably like gonna detect it as a wall and
Yes,
maybe
that's
make my
yeah. That's why I was saying there should be some form of mechanism within your wall detection algorithm, right? That makes the robot be able to choose or understand the difference between a wall and an obstacle, right? Otherwise, yeah, definitely you run into that problem. I think if you remember from the first time we had it face the center, it it was going around that
so
big obstacle. It's because of that, right? It's considering that to be the wall itself. So when it isn't.
so usually return all the points. Let's see how many points you return. There's so many. Will return to position. So 77 points, the total 5.67 meters. And then since we didn't move these zeros, we only moved X and Y's. These are all the record points that's it sent to me.
And it managed to stop, right? If I see correctly there.
Yeah.
Hmm.
So I was wondering, I don't know, 5 centimeters for I feel like my code isn't really like as smooth. So if the threshold is too small, it has some problems. It works, like
Yeah.
it
So
will return.
so a resolution will always affect you in many ways, right? So how fine you make something, and I think this is what you're also noticing here, right? So it's very. That's why I was asking what frequency is that node running at, because if it's slow, you may not be able to get the robot to um, assemble quick enough to be able to notice that, oh, actually I've reached my initial position, right? So um,
Mhm.
but yeah, oh, wonderful presentation, Sangdon. So thank you so much. And anything else that you just want to say in real quick about this? What was your most difficult part? And just to wrap it up here.
Uh, so I think you should understand the communication between clients and servers
Mm-hmm.
and make sure that what you want to do, what kind of data is that you want to transfer uh, between client and server. So let's say you have, I mean, we didn't have any goal for this
Mm-hmm.
because like you pretty much follow the wall. but you want to make sure that what kind of like values that you want to send over and what you want to print on the terminal. And there were some things that you have to be careful, like for instance, you have to have like the result for your action, especially, and then you want to make sure that you have the add done callback for your result, so you have all the result when they're all ready, and the client will pretty much post the result based on if you succeeded or not. You just want to make sure that you have your clients and servers communicate properly, and the steps of it is crucial too. So make sure you do that. And the thing is that you want to make sure that you want to have like different call groups for your subscribers
Mm.
and your servers, like actions and servers.
Can you
Uh,
explain a bit in more detail why it is very important for you to have them in separate groups? Because I think that's a very important thing.
because it's because when you're like sharing same values, for instance, we're using the lasers
Mm.
and we are using the ranges of the lasers. While we're doing that, we're pretty much gonna you're gonna have like a laser callback
Mm-hmm.
and you're gonna use the information in your it could be your like a server loop or like action. You don't want to have same values running concurrently. You just want to make sure you want to separate them. So you don't use the values that's currently the is using and then what the action is using. So you want to make sure you do that.
Hmm. Okay, so this is more. It sounds more like you're saying that you wanna create copies of the data that you're working with. Is this what you're saying?
That's what I did, and you want to make sh because for actions and servers,
Hmm.
you want to run them concurrently.
Okay,
But I
so
mean,
you wanna separate the data copies they're working on to reduce what? Uh.
the offsets because you might use different values for actions when if you are using all them in like the same callback groups,
Yeah.
if you don't separate them, it might get mixed up. Um, for me, I wasn't able to start this code because I didn't separate the
Okay, so there was a data race condition. It seems that's what's going
Mhm.
on here, right?
Yes,
And
and
okay,
and
so go ahead. Sorry.
if you don't separate them, it's not gonna move to the next step. So for instance, if you have for me the wall finder, this is my wall finder logic,
Hmm.
and while I didn't put it in the different callback groups, I was having a hard time for me to move on to the next step.
Hmm.
So I'll just make sure that you want to use the subscribers. For me, I feel like the best way is for the subscribers, you put in the mutually exclusive callback group,
Mm-hmm.
and for certain clients, you want to run them concurrently. You put in the re-entry callback group.
Okay, so for subscribers, why did you have, or why do you feel strongly that you have to put them in a mutually exclusive callback group, right? Because what if I want to get the data at the same time, right? So you kind of have to convince me here why.
Because I know that for the re-entry and callback groups,
Hmm.
you can on the different threads like all at the. I mean, you gonna pretty much use a multi-threaded executor for your codes at the end right here for the executor.
Yes.
But I know that if you do the re-entry and callback groups, you can run multiple callbacks in concurrently,
But
and because
I,
yeah.
I think my question here is why do you have to force the subscribers to execute one after the other, right? Because you said I think that um I'm trying to reiterate what you said here. You said you think it's best to put subscribers in a mutually exclusive callback group, right? Yes, and what that does is it enforces order of execution on your callbacks, right?
Yes,
That are in that group. So
yes.
that's what I'm trying to say. I'm trying to
So
understand.
it's gonna do it sequentially, even though it's gonna do it, it's still gonna run like different mutually exclusive callback group concurrently, but it's gonna only run that callback in one group. So if you create the multiple mutually exclusive callback groups,
Mm.
it will run differently. But if you want to run like something sequentially, you definitely might want to. I think one's synchronous and one's asynchronous. I'm not sure. I'm still
Mm-hmm.
remembering from the topics from the course, but
Yeah.
that's why I remember that I used the subscriber for the mutually exclusive callback groups. I
Mm.
uh I think I should have these in my.
Yeah. Okay. No worries. Thank you so much, Sangdon, for going to large extents of trying to explain this. We think it's very important for you to understand. That's why I was also asking you. But we're running out of time here, so let's just wrap it up, and then we can finish our conversation on Zoom. All right.
Mhm.
All right. Alright everyone, this was Sangdon's presentation, and good warm congratulations to him, and would like to thank him for getting the courage to come and make a presentation so that we can all learn, and he also is able to showcase his work. So I'd like to encourage all those of you who want to try the courses that we offer certification on to do so, and then you can book your slot and come and make a presentation, showcase your work, explain your approach, why do you think it's better. And as always, keep pushing your ROS learning. Bye bye.